So part 2, constants. Declaring local constants, the keyword is final. So you know from excluding this part, this is actually declaring a memory location. Put the final in front of it, now it's unchangeable. That means that if I try and do this, oops, am I recording yet? Yeah, it looks like I'm recording. Okay, so if I try and do this, this is a good thing because in Python, this would be just a syntax error. But the naming conventions, capitalize it. That's a universal one, except for Python, which, yeah, I'm not going to say anything about that, but that's bad. And Microsoft language, but Microsoft, I can kind of see why, because they have such a big language. It's for VB, Visual Basic, which doesn't exist anymore, but still, it's part of the syntax. They've got programming built in for Word, Excel. You can actually write programs to augment the Office. They have so many constants that they preface it with WD for word constants, for instance. But otherwise, capitalize it. Where do you do it? For now, they're just local, so they only exist for life of the function. Put it before your variables, because your variables, say you have an array that's dependent on a constant, that's size, you have to declare it. Declare it as constant before the array can use it. That's a common convention. And this capitalization isn't a TAM thing. I tend to be strict about it when I'm making up my marking keys. Not sure about Professor Hudson, but here's an example of the API for one, class math. They follow that convention, and it's even more useful in other cases for graphics. If you're setting colors, one approach is setting the red levels from 0 to 255, blue and green in similar fashion. Trying to remember something like mauve, what combination of red, blue, green? That's just dumb. So there's a constant, for instance, maybe for pink, or maybe not mauve, it's not popular, pink, and it automatically sets the integer color levels for you. Ignore that Python approach. Capitalization, you should follow it. If you have extra long words, then capitalization, you can't use camel case, obviously. Then use snake case and separate each word with the underscore. Math operators, same ones as in Python, except for, well, the exponent, I can't remember in Python off the top of my head. Anyhow, exponent, there's no operator. Some languages do have an operator. You have to call a method of class math. Division. Division in Python is, there's two quick review is, you use that slash operator. If it's single slash, it always results in a floating point value. Only if you use a double slash, do you actually get an integer value. But in Java, it's different. What determines the type, essentially, is the type of the inputs or the operands. If you don't know that term comes up in computer science, especially I think in CPSC 3.5. So if you have all integers in Python, then the result's going to be an integer. Only if at least one of the operands is a float is the result of float, or both. And I think these ones, oh, someone's asking. Well, yeah, I think it was a double star, but I just had a mental block. It's not a huge deal anyhow. Someone said the operator, because this isn't a Python class. And just, oh, it closed down in case I need it for the part 2 ones, but I have a lot of screen grabs here. Post and pre, oh, small thing. These are decrements. If it's increment, well, I can fix this small. Increment, copy paste error. So Professor Hudson made some, I make some. That's the increment. And it's a shorthand notation for this. When is it used? It's commonly used, but not exclusive for loops. So rather than the I is equal to I plus 1, whoops, I plus 1, that's good enough. They can use that, whoops. So it makes it smaller because you have multiple expressions. And we have 3 instructions here. So recall, each statement or instruction has to be separated from the other semicolon. Now, the post and pre, most of the time, actually all the time, if this is the only operation on that line, they're the same. So whether you do pre or post here, it's not going to matter. The only time that pre versus post, increment and decrement make a difference is when you have another operation, like a method call. And the decrement is decreased by 1, fine. Now, this example, this is where the screen grabs. I'm trying to do it to make things faster rather than fumbling around even up the command line or IntelliJ, because I'm trying to make up some time here. Okay, whoops. So in this case, very easy. Now, I took out the letters, but it's easier for you to see if you look at in a trace, because you have numbers. It's hard to tell which one goes with which print. Okay, so it's 5. That's straightforward. We increase it, it's going to be 6. That's still straightforward. That's the post, that's the pre. It's still going to increase it by 1. I said if it's the only instruction on that line, the two are the same. Now, or in that block if we have a loop. So at this point, let's see. Yes. So we go back here. We're not doing increment in any of these ones in the call to print. We do the increment outside of the print. In this case, the difference is we're going to pass to it a string. The first part of the string is this. The second part is an integer that's going to be converted to a string, and a converted integer is going to be concatenated here. Now the question is, do we increment num before the method call or after? That's where so it's either, do we run the method first or do we do the increment first? That's where the pre versus post makes a difference. And it's pre, so we increase num and then pass it to print. And then when we display it here, well, it's still 8 because we've incremented it already. It doesn't increment after the method call. Over here, choice of the method call or the increment, we do the increment afterwards, so it's an 8. But then after the method's done, we check, it's a 9. And that's why I have that last one here. So this illustrates the pre versus post, one example. You will see some other ones. If you look at pre versus post, they actually have that in which about C and C++. You might see expressions, so you can try to figure out these ones as practice. If I created an x is equal to, I create an x, y, z. Now this is not great style to do these all in one line by doing it quickly. X is equal to 5, for instance. And, well, okay, so suppose we set x, y, z to some values already. We're trying not to use too much time here. So we do a pre-increment here. We say do a post increment here. And then we have some operator. This is something you can try hand tracing, see if you understand it. What do we do first? Well, that's one for you to try out. But you should be able to handle this based on what you've been taught, how to evaluate this expression. There's a few things. There's an assignment, there's a pre-increment, post-increment, multiplication. How do we evaluate this? And give some values for x, y, z, of course, or at least y and z. And then you can have a print of x, y, z after it and see what the values are. An extra suggested practice. Other Java operators. So this part, I wouldn't have talked about these ones until I got to branching and looping, but in case you're wondering why I jump ahead, I had to be able to just remind you that's what it is. It's for when you're relating things in a Boolean expression. The Python logical operator, the Java equivalent, different symbol, same operation. Assignment. So this is something that exists in Python, but I didn't talk about it for interest of time because there's not a lot of time, and I wouldn't have talked about it in Java unless Professor Hudson had it. The assignment's still the assignment. So there's no alternative in Java. Sorry, these are both Java here, but this is equivalent to this, a shorthand. So it's plus equals to, this is minus equals to, this is times, and so on, shorthand. I tend not to use these ones because it's a little bit less clear and it takes up some time. So these operators, screen grab of the output shows you, okay, we have 2. Then we increase it by 1. That's why we get a 3 here. We multiply 3 by 3 times 2. We get a 6 here. 6 divided by 2. We go back down to 3. 3 minus 10 minus 7. Just to illustrate a nice simple example how they work. Casting. Casting is when you're converting between types, but this is where sometimes people use an incorrect term. They say casting in Python. Here's how you do casting. You're converting, but you're not doing casting. Input function in Python returns a string. Python 3. If we have a value that we want the person to say type in an integer, we call the int function. That's actually not casting. INT only takes as input a string and returns, if it can, an integer equivalent, but it's very specific in the conversions. It's just a conversion function. That's actually not casting. Casting can convert between, it's an operator between any arbitrary type as long as it makes sense to convert. So you can convert, say, between integers and floats and integers, but you can't say convert between a Boolean and a number. This could show up as a, depending on what Professor Hudson has in mind, as a useful concept in object orientation. We talk about OO. The general format is we have some expression, it could be a constant, it could be a mathematical, it could be just a constant like that. But a constant is an expression. And then inside the brackets, what type we want to convert to. And then as long as it makes sense, and as long as when you're running Java, the runtime environment knows about that type. What do I mean? Well, if you have a new class, the runtime environment has to be aware of that class. It has to be included as it's running your program, as opposed to it somewhere sitting on the internet. As long as it can be converted, the types make sense, then it can do it. That's actual casting. So the rule of thumb for casting, the simple rule of thumb. If I have some piece of information that contains more, and one memory location that can contain more, say real numbers, and one that contains less, integers, you should know from, I recall this from high school math, they showed set theory, or at least they reviewed it. You've got the set of numbers, you have a set containing all the integers, positive and negative whole numbers, and that set was contained within real numbers, because real numbers can include whole numbers. So the more, if we have variable that it's a floating point, it can contain integers and more. So we can go from an integer variable and without any problems or conversion, put it inside a float. It doesn't have a decimal point, but that's not a problem. It has less information. But what we can't do in Java is take that more, have a floating point because it has a decimal. The integer variable doesn't have the ability to store it. It doesn't do a truncation rounding. Keep that in mind and you won't have trouble with this simple example of the casting. So we have an integer num1, a double num2. Num2 is set to a value of fractional portion. When we go from num2, take that value, we need to actually cast to an integer because this is more. This can't contain a fractional value. So what it does is it truncates, doesn't round. And I have an obvious one. When we display num1 and num2, see num1 is a truncated value of num2, 1.9. However, going the other way around, we take what's in num1, which is still 1 here, we displayed it, and we put it in num2, which is a float. That's fine. It just adds in a 0.0 to indicate that, yes, it can store a fractional value to the right-hand side of the decimal. This is a simple example of casting right here. And we can have other types. If it's one that makes sense to do it, then it'll perform that operation at runtime, at compile time, if it makes sense. If it doesn't make sense, then it's going to say compilation error if you have a string and a Boolean, for instance. Operator precedence. This you know from, I recall actually being taught this, the so-called BEDMAS in elementary school, simple math. And you have been taught this again, a little more complex, at least in 231 and more. You know, the BEDMAS, multiplication, it's a little misnomer here. Multiplication, division, same level, but the bed multiplication implies it's before BEDMAS. Division before multiplication, but it's not, it's left to right. So essentially, I say first because brackets are always first. And if we have inner brackets, that evaluates first. So evaluate the first row first. If there's nothing applicable in the first row, then we do second row, the post and the pre. See what the post pre. And now, the third level, it's only one, the negation, mathematical negation. We can do, we can have a plus here, I suppose. I think the syntax allows it. So positive and negative can become a positive. Same way a positive becomes a negative. Or logical, true becomes false, not equal to. And here we can see, okay, if we have ones that are in the same level, then we typically go left to right. And the rest of it you should see. So now you should be able to figure out the one where I had that x plus plus y multiply Z++, you should be able to figure out the assignments at the very bottom, as well as the variations of the assignment operator. The string. Time here. More on the string type. What is this? Some weird, there we go, 345. Okay, the string. The API for a string for reference. It allows us to create this without calling constructor. You can call a constructor. I think I had an example of it where I said new string and I passed the constructor method a string. But the reminder, use only double quotes. Don't use single quotes because that means the character. You can't mix and match directly. How to access elements? You can't use an index unlike Python, but you call the chorat method. And it goes from index 0 to length -1 because we start counting at 0. We have 2 elements. The index is 0 and 1. And that means because it's length -1, if we want to access the last element, then it's length -1. 2 elements, the index is 1. Determining a length, it's just calling a length method. Concatenation, same as in Python, the plus, if we're dealing with strings. Checking for equality. This is where there's some debate here. You can actually do this, say in a branch, with the latest version of Python. You can't do this with other classes. That comes up as a lesson here. Why it allows you to do this? Well, we're debating. Professor Hudson said he wanted to check it out, but this does work. If you look at his notes, it seems to imply or say straight out that you can't do this. He is correct. When you're dealing with an object, you have an address, and this is comparing addresses. But with the string, it's actually comparing data. Now, in general, with classes, there is equals method that is either pre-written or you write. This one always works if this doesn't work for other classes. But with this example, I did write a little test program because I recall in the older version of Java, this would not work. So we have 2 strings here, and I'll do the comparison later in a bit. ABC, they're obviously slightly different because of the case. First off, the number, oops, this one's covered here. The number of characters in this string, 6. Fine. The last index, the element at the last index is going to be F, and it's length -1 because it's 6 characters, but it's index 5. Now, oops, someone's coming in now. It's kind of okay, better late than never. Now, these are 2 different values. This is ASCII 65. This is ASCII 97. We try and compare it, it's going to say they're different. In order to determine order, essentially, it compares the ASCII values. So this is going to compare S1 and S2. S1 is 65. S2 is 97. It's going to come up with -32. Because if the ASCII code is lower, it comes earlier according to its ranking. So it's going to be less than 0. So S1 is before S2. Nice, simple little example to see. The other way, so we ask with the same strings, is it greater than? Well, it's -32, this expression. Is it greater than 0? No, so we don't get that output. What we have here is we have the string, and it's concatenated with the true-false value returned by compare to. In this case, it's true, it's -32. In this case, it's false, -32 is not greater than 0. And we can see the full result. Oh, I have the copy paste here. Now the comparison methods, the identical, well, it's -32, so it's not going to return 0. It's false that they're identical. That's how it's comparing these. If we want to compare to, the compare to is case sensitive. So we actually say compare to, what does it return? It subtracts the 2, we get the -32. That works. 65 minus 97. But if we do an insensitive comparison, it's converting either this to lower or this to upper. It doesn't really matter. The 2 are the same ASCII values, and it returns 0. So that's how the case sensitive works by default, case insensitive. And the API can be handy because then you can look at the methods that have been defined. Look at the ones, if you can't remember the name, now you have a basic understanding. Look for the name, and they give you a brief description to help you remember what's what. And over here, now the last one I'll go through is we're comparing these strings. This is the one where we had some debate. The older Python wouldn't let you do this because it was comparing the address. This is a string in one location. This is supposed to be a string in another. And if it's not pointing to the same string, it's going to be false. But it's comparing the characters, even though they could be two different strings. And it actually shows this message because this is true. The data is the same. Whether or not, well, actually, I won't get to whether or not yet. But this does work with strings. It doesn't work with other classes. That much you should know. However, other classes, either an equals method has been written that properly compares them, compares basically character by character and sees if they're equal. If one's not equal, then it's false. Then you can either use if it's been written or you have to write your own equals method. Okay, so this is, I've caught up between lectures. Good. You guys were slightly behind, but I was able to do a quiz. As I note, this is where I left off. Equality operator. So if the equality operator with newer Python, it will actually show these as being equivalent, but with other types of classes objects, you actually have to use equals. You can also use the equals method with a string as well too. More on this later. We talk about branching streams. Oops. Now, this is one where example where I actually go slower than you. I take more time to go through this than the other instructors. Professor Hudson's core notes, the ones they provided to give us an idea what level we're covering, he talks about, he has two instructions essentially, and just has a system.out print and system.error. Presumably hopefully spends time actually explaining it, but it's hard to tell what difference is print and error when you just are running a regular program. So first off, what's happening? You have your computer program and user. The information that's communicated, the text information, is communicated. The term is actually a stream. The stream of characters for text information. System in. And if you want to look at, this is a Python specific.
Yo.
Yeah.
Right away.
Oops, so how come someone's talking in the middle of this? Is there a question or? Oh, okay. Okay. Oh, someone made a mistake here. I thought maybe there's some drastic thing where it wasn't, you couldn't see the screen. Okay. What was I saying now? Oh, system.in. This is the Python implementation. The general name for the stream of characters coming into a program is the standard out. Standard, like standard transmission and standard in, sorry. A bit of a, threw me a bit there. A little interruption, my thoughts were lost. Standard input. If you want to read details. System.out is the implementation. The general concept is a standard out, but they call it system out because, as we see, this is actually class and an attribute. Now, this is the default information stream. When you use print in Python, it's going through the system out. The implementation of the system out is, the standard out, not the implementation of the standard out is system out. However, there's a third one, because there's potentially the ability to stop that stream of output. You might think, well, why do I do it? I'll show you an example in a little bit. If that stream of output from the standard output is, then you can actually stop the standard in, but the standard out is easier to see. One way of doing this is called the redirection of output. The redirection operator here, it looks like that greater than or equal to, but I have an example. This works outside of your programs, outside of Java programs, using the ls program, a Unix Linux command. And what you're doing is, by default, ls, that stream of output, goes through the standard output. But by doing this, you're stopping that output and redirecting it, telling it to go somewhere else. And you're telling it to go be written to the file that you put here. So it's going to create the file that doesn't exist, or it overwrites it. So you get a file created. Now I'll explain why you would want to do this in a bit. Now, what you don't need to know is essentially the redirection of output, say for a quiz. This is the extra, but I'm using this extra to explain what's the difference between standard out and standard in. There is a case, now this is where standard error comes in, where even if you redirect the output, say something goes drastically wrong when you're typing ls, or the equivalent in Windows, dir, that's showing contents of directory. If there's important information like error messages, drastic ones that you need to show, they won't be redirected. So that's the difference. Standard error is a stream of output, but it's output that can't be redirected. It's a separate stream than standard in. So example, this, just by showing still screens, it doesn't work so well. A live example here. And I'm going to use a command line because I'm not actually dead certain you can redirect, do the redirection with an IDE. And normally you wouldn't want to. This is pretty low level stuff closer to the operating system. So if I am typing a command here, dir, it shows me the contents of my current directory. Yeah. Now this isn't a very big directory. This is kind of like ls. But it's very conceivable that, say, if you go to the undergrad directory in computer science, you're going to have a long list. Or this isn't just for operating system commands. This could be for your program. Your program's doing a lot of stuff. There could be a lot of output. If there's a lot of output and you want to study it, what you might want to do is redirect it to a file. Right now, oh, I ran this in this, so I'll call it cams out just so you know it's going to create a new file here. One thing, see, now dir didn't show the contents of directory. I said all this output is going to be redirected to a file. And where the heck are we? We're in the examples directory. Cams out. Okay. And see, we can see the contents of this. And if a complicated program, you're going to get a lot of output. Fine. You can do this with a Java program as well, too. Programming induction part. I have a program to illustrate this. Where's the part two? Part two. Let's not save time by opening it, but stuttering. Didn't have Zoom this morning, so it wasn't quite as many windows. So to illustrate the difference, we have a program here. Before I run through the program, an explanation of what these are. System now, system, it's capitalized. It's a class. And here's the API for a class if you want to look at it, class system. That's why you have to have that system. Now, out, if you look through this, is actually an attribute of class system. The type of it is, it's an attribute, and that attribute is a class print stream. So we've instantiated a print stream object called out. This is why you need this exactly. You're accessing class system's out attribute. And that print stream has a method called println as well as print. So that's why you need all this stuff. And you can look at the definition for this parameters, but it's taking a string. Okay, that's the explanation for why you need all this stuff besides it's needed for the syntax. And just to show, it's assumed at least you have seen object-oriented programming in Python. So I'm just showing you how this looks in actual code, not Java, because you don't know Java syntax for defining class, but system is a class. So we've defined an attribute. This is an attribute of class system right here. However, unlike Python, we can specify the type, and that type in this case of type print stream. And that class print stream, I don't have a definition here, but we're going to have another class print stream. It's going to have a DEF or println or the equivalent in Java. Fine. Oh, maybe I do have it here. Forgot. Okay. Now, what's the difference between standard out and standard in? I went into all this. Actually, I took the time to show why what the heck all this is besides syntax. Most cases, the standard out and standard, so this is writing to the standard out, this is writing to the standard error string. If you run this program, whether it's through oh, this is part 3. Oh, it must be opening by default in the same window. I've got part 3 open. Here I open. I know I've opened part 2, so it's faster. Streams. Run it. We'll see both messages. Oh, dude, it's that bloody slow. Okay, there you go. So you see the out and the error, and it's color code just indicated it's a little different. Still, you're saying, well, aside from the color here, what's the bloody difference? Well, if I go to the command line, run this, by default, it's going to be the same as well. No, it doesn't color code it. It's saying, well, whoop-de-doo. Now, I have to take the time to show this with the Unix redirection, really just to show the difference, or the redirection. We called it bloody well Unix redirection, but it's not Unix specific. Streams. So rather than having the output appear in the standard out, basically the screen, I can have it overwrite. What the heck was it? Tams. Well, it doesn't really matter. Tams out. It'll either create a new one or overwrite it. Notice the difference. In this case, both streamed, the contents of both appeared. In this case, the output stream didn't appear. But the error message where you have drastic things appear, that's what these standard errors. You can't stop that output, nor should you. And that error stream, standard error, is used for those important messages that always have to appear. And if you dig, you should try and get this program, download it, and run it, fiddle around with it using this output, and then look at the results, and you'll see a file, whatever you call it here. Now, running this through, this is a higher level approach, and this is lower level. You have to have an understanding of the operating system, and so a little bit here. Whether or not you can actually do the redirection and see the difference, probably not. Well, I don't know how. I don't know if it's possible here. And I say probably not, because this is such a high level, you won't want to do things like this. But the learning lesson, to recap again, this is all Professor Hudson has in his core notes. So really understanding difference is hard to tell from this without all its demo. This is what you should know, the difference between these two. And when there's a difference, when they're the same in terms of the quiz. If you need to know more, like the Unix redirection, then this is my extra. But the extra is just to show you this. While I'm at it, because this is a useful thing, it's not in a quiz, but it's still useful. So one way of dealing with output that's too long is using redirection at greater than. Another way is to use a concept, an approach called piping. The vertical bar. The piping works with Linux, Unix, or with Windows and macOS if you're using terminal, because it should be running Linux commands. You have the output of the program piped into another program as input. So the more, oh wait, yeah, I think, yeah, more exists in Windows. For a second, I wasn't sure, but I remember writing this in the morning. So what it did was, the more displays a screenful at a time, and it's not dynamic, where it looks at the size of your window, so it arbitrarily counts lines. And the more, if it's more than a screenful, it stops there so that you can, until you actually want more, continue. Oh, and unfortunately, it was right at that length. But if it was multiple screens, you could go a screen at a time. Another useful way of dealing with output that's too long from any program. The only extra caveat I'd say is when you try this out, whether it's redirection or whether it's piping, if you have an interactive program getting user input, these are meant to be automated ones. No, it doesn't get user input. So it doesn't get user input when you run the program. You get it at the command line as you run it. So it'd be the equivalent of command line arguments would look like this. But my program isn't set up to actually do anything with command line or so it's the same output. So if you have piping or redirection, then you should set your program up so that the input comes here, because it's going to be a problem. You don't get output, so you won't have problems here. These are still screen grabs, but it might be hard to tell what's happening. And you probably should play around with these a little bit because they can be very handy outside of programming. Okay, getting text input. And I have to pick up the pace, but it was that theory and the IntelliJ and the admin stuff that really slowed down. Text input in Java, I'll say shortly, is that the short form is, it looks like it's much more work than in Python. It is, but it is a significant improvement. In the past, it was very hard in Java to get simple text input. Stupid implementation. And people wrote extra libraries that people had to import. They weren't part of Sun's library. Now it's actually, you don't have to do, you don't have to import external code. So it's still a lot easier. One way of doing this is with the scanner class. So it's a built-in Java class rather than importing someone else's library in their classes. It's part of this module, Java module, but the utility module, it's not counted as being common enough like println, where it's included by default. So you actually have to import it. This is a submodule, and this is the class name. And we're just importing out of the utility module, just one. We don't want to import them all. That's bad style generally, because we could have a name of a class that coincides with R, and then we get a naming conflict. Now that we actually know that name scanner, because if we didn't do this import, you wouldn't know what that name scanner is. It's telling our program, okay, here's a name, here's where you find information. Then when it's aware of the name, it's like using a library in Python. You have to actually import that name library before you can actually call methods or functions. Now we can instantiate. The terminology they didn't use here in 231 is you're creating an instance of an example variable that's a scanner object. And this is a syntax. Now this part, after I said the system in, this is basically the Java implementation of the standard input. You're saying the standard input is going to basically be processed, if you will, through the scanner object. So I'm creating an object of type scanner here. Syntax is different from Python, but the idea is the same. And now that I have an actual instance, I can use this reference to the object to call methods. And there's one method. What are some methods? There they are, and a shortcut link to the scanner class. You don't need to know all of them. When I teach it, I want to go into OO faster when I'm teaching by myself. So I was looking at the schedule. With our schedule, we don't get into OO, how to write classes and objects from what I see till week 6, 7. But he talks about extra things I don't. I just have how to get an integer, how to get a float, how to get a string, and then let people look. But you can see there's a whole bunch of different integers. So if I have instantiated something called the variable is called in, now I can use that object to access the different methods here. And this is what it's returning essentially. I just showed this, the return value from that method being stored in a variable. And I don't have great names, I know, but I'm trying to fit it within a screen without having micro font. It's not bad when you're at home, but when it's in person, they can't see it if it's too small. So your import, it's at the top of the file, because now anywhere after this in the file, the program knows if I try and call the scanner constructor, now it knows what it is. The standard convention is putting it at the very top, even before documentation. So I have two variables to store my input. Not a huge deal. Over here, this is going to be, as I said, this is a class. This is going to be a variable that refers to an object. What am I doing here and here? That'll tell you what I'm doing here. This is setting default value. This is saying default's an empty string. Now with objects, I said, you have a reference to the address of something. I haven't created an object yet, so the standard to indicate that I haven't created an object is almost every language. It's calling it null. What will be stored in the input object is a numeric address in RAM. But null is a standard saying it points to no address. It's actually 0, but 0 is sufficient to point to nowhere because 0 is used by the operating system. Now that I have this object, I create a scanner object, and I say the input, standard input, is going to be processed through this, and I have the prompts here. The name is a string. Next line, if you look, next line returns a string. Next int returns an integer. Fine. Very simple getting of input. And I run this program, getting input. Unfortunately, this is where the command line Windows doesn't have that completion as good as Unix. Just to show. Oh, I typed it through the command line. I can do it through IntelliJ here if I wish on the next one. So it got the input. Fairly simple. Fine. But there's a problem. This isn't a Java specific problem. You'll see it in other languages depending on how they read input. When I'm typing in information, people coming in late here. In anything, in an editor. Pull up something. Okay. I type in information. I type in information. And then I want to have the next information appear online. Of course, I hit enter. It doesn't move it to the next line magically to have the output appear next line. When I hit enter, that information has to be stored at a low level. The storage of the pressing of the enter is 1 or 2 characters. It's called the end of line character, depending on the operating system. When I run getting input here, change here, getting input. We have the first prompt. It's looking for a name. Where the heck is it? Right here. I've typed in my name, but nothing happens because it's still waiting here. How does it know that the standards? How does it know that I finished my output? Even in a web page, if you hit enter, that's when you say, I have finished that input. Or there's a button, but there's no button here because it's text. I have to hit enter. So that enter is stored. Back here. That end of ELL character is part of it, comes in the standard input stream. Right here. Next line, I've underlined this here, the whole thing. It looks through this and says, oh, these are all characters. And the end of the input is the end of line. And it doesn't put the end of line as part of my name, but it gets it off the stream. The stream is a buffer, essentially, a memory buffer. And it puts James Tam, as you saw. Name refers to it, that variable. So next line stores James Tam in that name variable. And the end of line isn't stored as James Tam because the problem, it might add an extra new line when it shouldn't. It'll push this to the next line when it shouldn't. And this is fine. But other types of ways of reading input, this is where you will have to know this. If you don't know it, you're going to have bugs in your program. If I get numeric input, it's age. I type in an age. How does it know that I'm done? What's the standard convention? Again, I hit enter. It's going to sit here all day till I hit enter. I hit enter. And then it proceeds past there. So it's waiting for the age right here. And now it displays the value after I hit enter. It's sitting at that because it's still waiting. The program pauses right there until I've typed in the input. Now, the issue is this. Any other of these methods of scanner, except for the one that reads a line, the string, it checks that's numeric. Yes, moves on. Numeric. Yes, it's an integer, I should say, not just numeric. And then it sees the end of line marker. It takes that 37 because the end of line marker, it knows that we're done with the number. And it stuffs that 37 in age because that's what storage is. However, that end of line marker is not an ASCII. It is an ASCII value, but it's not an ASCII value from the digits 0 to 9. So we don't want to put that end of line marker in there, but it leaves it on the string. Now, when our program ends like the other one at this point, we're not getting new input. That end of line marker gets flushed from the buffer when the program ends. But if we still continue to get input, and we need specifically string input, we're going to have a problem. Okay, so this is another one. I have the complete program. If we're getting string input, well, how do we know that we have the end of input? The end of line marker. And the string is the same way. Well, next int. Oh, I made a mistake here. Didn't notice it this one. It would be next line here. My mistake. Where the heck is it? Next line. Copy paste mistake. No one noticed it this morning. I didn't notice it this morning. Next line. Next line is trying to read a string in the name. Well, it sees that handy dandy end of line marker. So it thinks we're done. We don't need to get input. So it's going to take what's in front of the end line marker, just like this, James Tam puts it into name. Well, it does the same thing. There's nothing in front of the end line marker, and we get an empty string, which, switch over here. And what's the program? Problematic input. Enter a whole number, 37. No problem, it's waiting, no problem yet. I hit enter. That enter sits in the input stream. So then when it asks for a string, wait a minute. What the heck happened? Well, the length of that string is 0. I have basically I'm displaying the string length. And the output, it's displaying 37. And then right after at 37, I'm supposed to have that string value, but there's an empty string and then the underscore. And there's a way of two ways of fixing this. So right here, see, next what the heck is it? It leaves that end of line marker here. So when we get to next line, it's reading this into a string. A string is the empty string. And then when we display the value, see it, int part of it, dash, and then it displays the contents of variable, int dash, and if I typed in 10, 10 appears here, because that's contents of num. And then we concatenate an underscore, so we're going to indicate just before the underscore is going to be the string the user entered. And that comes from here. But the user didn't get a chance to enter anything, as you saw, because that EOL is already on the string, it's still saying on the string. So there's going to be an empty string here. And then whatever the user entered is between these two underscores, which is an empty string here. And this isn't Java specific. And just to show you it's an empty string, if you didn't catch it, a string length, that's why we had a 0 up here when we ran the program. Nothing between here because it's an empty string. Okay, how do we fix it? There's two ways. Well, actually, there's one way of fixing it. There's one way of preventing it. To fix it. So that's after the fact, in case you're wondering. So it's like getting ill, then how do we treat it? That's the fixing. Preventing is don't get ill. Okay, the fixing part is, well, remember right here, if we type in 37 and we hit EOL, that EOL is sitting in the stream. Which method gets rid of that end of line marker? Next line. So we have a call the next line here. We don't use it, but we basically just get rid of the end line marker. Because the buffer is now empty, when we call next line here the second time, it's empty buffer, then it allows us to enter in the value. We could, because we don't care about storing that end of line marker, we could just do this, not even store the return value, because we don't care about storing that empty string. The idea is getting it off the stream. And then when we display it with this fixed version, clear the screen so I don't lose much clutter. Now I get the ability to enter in a string. And you can see what's between the two underscores is the string I entered. Now we have another approach, that's the alternate. So this one fixed the problematic. It got rid of the end of line marker sitting there, but it fixed it after the fact, got rid of it. The second approach is the Python sort of approach in a way. Approach 2. So it's prompting again, showing approach 2. So the first approach, when we want to actually get a whole number, we read it as a string. That's possible. That's how Python does it. Tempnum is just a string. And then we can convert tempnum using that parseInt method here to an integer. And again, if it can't be converted, just like in Python, we get an exception. So this is preventing the problem because we don't have that end of line marker sitting in the stream. But the end effect is the end of line marker is gone. So now when I get to the next line here, I do have the ability, oh wait, actually I have to show this the second time. I hit 37, I hit enter. It yanked out 37 in the enter because it's read as a string. And then I have the ability to enter and just prove that it's actually taking the user input. You'll see that in the string between the underscores. So either approach is acceptable. And this isn't a stupid Java thing. C has, depending on which method you use, has this problem. And this can be a really nasty error because I had said in 231 testing, you should, in some cases, test the input. And you thought, this guy's really anal retentive. Who would want to do this? But you see, I'm testing it right here and just making sure that the string was properly read. This appears here. In a real program, I've seen students do this and they didn't listen to me. And they actually forgot this lesson. And they proceeded with a fairly big program. They had a logic error. The problem stemmed right to, they didn't get the value properly, the string, and they weren't aware of it. So they had a logic error because the string was off. And then trace it back there, looking at the string processing or number processing, and that's not where the error is. The error is right here. But if you outputted the value, you would have caught it even before you wrote the rest of the program. So that's why it said in 231, even getting user input, there's certain times that you want to test it. And a very simple test is just echo back on screen what you got as input. And it could be file input, it could be user input. Okay, I quickly said there's methods to convert. There's the parsed, and there's the other classes to get the other types as well too. So it converts from a string to the target type. Now this kills a few birds with one stone. One is it's showing you how to get, if you've got string input, how to convert it one way. There's other ways. The other thing is when I talk about wrapper classes, well, why would you need functionality of a class? Here's an example. And I alluded to this. I said there's methods to convert from string to other types.